In this video, I'm going to be showing you how we get the formulas for each of these conversions. And the formulas derive from things that you already know. All right, so these we just saw are the formulas to get x and y, and the formulas to get r and theta. All right, so they all actually come from the ratios that we learned previously and the equation of a circle. Okay, so let's take a look at how we can get from this to each of these. All right, so let's go ahead and start with how do we get x and y. Well, x and y actually come from the sine and cosine formulas. So remember that sine of theta, the ratio for it is y over r. And for cosine theta, the ratio is x over r. So really, it's just one step and we get what we need. If we want to isolate y, because remember that if we're going from a polar to a rectangular coordinate, we need x or y. What I'm going to do is I'm just going to go ahead and multiply by r on both sides, right? And these cancel out, and I end up getting a formula for y, which is r times sine theta. And that's exactly the formula that we have up here. For cosine, what we're going to be doing is we're going to be solving for the x. Okay, so I'm going to do times r, and that cancels out, and so I end up getting x is equal to r times cosine theta, which is this equation up here. So it's really just rearranging some information that we already know is true about circles. All right, and so polar graphs are circular graphs, and so it makes sense that all of these formulas derive from these. Well, let's take a look at how we get r and theta. So r comes from the equation of a circle, and the reason that we want to use this equation is because when we're going from rectangular to polar, rectangular means we have an x and a y, and it's going to give us a radius, which is what we need. So if we do x squared plus y squared equals r squared, the only thing I need to do to solve for r is I need to take the square root of it. So I end up getting r is equal to the square root of x squared plus y squared. All right, and in this case, we're only going to be taking the positive. And then lastly, for theta, again, if we're going from rectangular to polar, it means we have an xy. Well, conveniently, the tangent ratio uses an x and a y, and we can solve for theta. So if we do a little bit of inverse functions, right, if I take tangent inverse of the left side and also tangent inverse of the right side, these tangents cancel out, and what I'm left with is just theta. So theta is going to be the value of tangent inverse of y over x. So that's just a little bit of information on how we derive these formulas. It's always best to understand how they work and not have to memorize them. So please realize that they do come from these ratios, the equation of a circle, and this is all information that you are all familiar with already.